All right, let's just jump right in. You've heard the two biggest buzzwords in tech, right? AI and quantum computing. For ages, they've been on their own separate, kind of mind-blowing tracks. But what happens when you smash them together? Well, that's when you get something that could change, well, pretty much everything: quantum AI. So, here's the plan for our little journey. First up, we're going to see why AI is kind of hitting a ceiling with the tech we have now. Then we'll bring in the hero of our story, quantum computing. After that, we'll see how these two are teaming up, look at the amazing things they could do, and also the really tough challenges. And we'll wrap it all up by asking the big question. Is this it? Is this the future of computing? Okay, so first things first, let's talk about the problem. I mean, AI has made these unbelievable leaps, right? But here's the catch. As these AI models get smarter and more powerful, they're literally starting to get too big for the computers we use to run them. They're hungry for a whole new kind of power. And when I say big, I mean staggering. Some of the top AI models we have today are juggling over 1 trillion parameters. Now, think of each parameter as a tiny, tiny knob that the AI has to tune perfectly. And it has to tune all 1 trillion of them at the same time just to land on the right answer. I mean, can you even imagine the amount of computing power it takes to search through a space that huge? It's becoming completely unsustainable, even for the biggest supercomputers on the planet. Because really, that's what AI is all about at its core. It's one giant optimization problem. Imagine you're dropped into a massive mountain range, and your job is to find the single highest peak in the entire range. That's exactly what an AI is trying to do. It's sifting through trillions and trillions of possibilities to find that one perfect solution. And this is where our amazing classical computers finally, start to wave the white flag. So, if classical computing is hitting a wall, how do we smash through it? Well, this is where the story takes a sharp turn into the really weird and wonderful world of quantum computing. And look, it's super important to get this. This isn't just a faster computer. It's not like going from a car to a faster car. This is like going from a car to a teleporter. It's a completely different way of thinking about information, all based on the strange, counterintuitive rules of quantum mechanics. Okay, so the key difference, the whole ballgame really, comes down to this: the bit versus the qubit. A classical bit, the kind in your phone or laptop, it's like a light switch. It's either on or it's off, a 1 or a 0. Simple. But a qubit, a quantum bit, oh, that's more like a spinning coin. While it's spinning, it's not heads or tails. It's kind of both at the same time. And that little trick lets it process a whole bunch of states at once. And this spinning coin thing has a name. It's called superposition. Honestly, it's the secret sauce. It's the magic that lets a quantum computer check out a massive number of possibilities all at the same time. Your laptop has to go through the list one by one, right? Check this? Nope. Check this? Nope. A quantum computer gets to look at the entire list all at once. It's a massive shortcut. But wait, it gets even weirder and more powerful. There's this other thing called entanglement. This is where you can link two qubits together so they're basically one system. The crazy part is, whatever you do to one, the other one instantly knows and reacts, even if they're on opposite sides of the universe. It's this deep, almost psychic connection that creates these incredibly powerful correlations, juicing up the computer's power even more. Einstein himself thought it was so weird, he called it spooky action at a distance. So you see where this is going, right? On one hand, you've got AI, which is desperate to solve these huge optimization problems. On the other, you have quantum computing, which is naturally amazing at exploring gigantic landscapes of possibilities. It's like a match made in computational heaven. So let's look at how this quantum AI partnership is actually being built to just supercharge machine learning. And in reality, it's not like we're just throwing out our old computers. It's a hybrid workflow, a team effort. Here's how it plays out. Step 1. A regular classical computer, your CPU or GPU, sets up the super complex AI problem. Step 2, it hands that problem over to the quantum processor, the QPU. This is where the magic happens. The QPU uses superposition to look at all the possible solutions at once. Step 3, it uses another cool quantum trick called interference to basically have the wrong answers cancel each other out while the right ones get stronger. And finally, step 4, it sends this handful of really promising solutions back to the classical computer to finish the job. They're working together. And researchers aren't just winging it. They're building a whole new toolkit of specialized quantum tools just for AI. For instance, there's Grover's algorithm, which is basically like a quantum search engine on steroids for huge databases. You've got quantum annealing, which is designed specifically to tackle those crazy find the highest peak in the mountain range problems we talked about. And then there are variational quantum circuits, or VQCs, which are the fundamental building blocks for creating what you could call quantum neural networks. Each one is a specialized tool for a very specific, very hard problem.
Okay, so this all sounds absolutely game-changing, right? And it is. But it's really important we stay grounded. We have to balance the incredible hype with the, let's say, difficult reality. So let's take a hard look at both sides of this coin, the amazing promise and the serious hurdles we still have to clear.
The potential here is just wow. We're talking about things like designing brand new life-saving medicines by simulating molecules with perfect accuracy, or optimizing global financial strategies in the blink of an eye. Think about creating language models that are light years beyond what we have now, or solving the nightmare logistics problems of global supply chains. This isn't just about small improvements. These are the kinds of applications that could completely rewrite how entire industries work. Okay, but here's the reality check. The reason we don't have these things yet is because this stuff is hard. For one, qubits are ridiculously fragile. The slightest little vibration, the tiniest change in temperature, and poof, they lose their quantum state. That's called decoherence. This noise from the environment messes up the calculations, creating errors. And frankly, we just can't build quantum computers with enough stable, high-quality qubits yet. Scaling this technology up is a monster of an engineering challenge. So, where does that leave us? Is this just a cool science experiment, or are we really on the edge of the next great computing paradigm? Let's zoom out and look at the future of computation. You know, this quote from the material we're looking at really nails it. It says that quantum AI isn't just an upgrade, it's a paradigm shift. It's about combining the very laws of physics with computation to finally attack problems that we used to think were fundamentally unsolvable. And that's the key, really. The whole revolution, the whole promise we've been talking about, it all really kicks off when we hit one massive engineering goal: building large-scale, fault-tolerant quantum computers. We need machines that are smart enough to catch and correct their own errors as they happen. Once we crack that, well, then the floodgates open. Which brings us right back to our big final question. By blending the incredible learning ability of AI with the truly bizarre and powerful rules of quantum mechanics, are we about to enter a new age of problem solving? An age where the word impossible starts to mean something very, very different? I guess we'll have to wait and see.